Hi my dear students, today we are going to discuss chemical bonding for EAP set. So first the problems or questions are discussing based on bond order and bond length, relations between bond parameters, next formula to calculation of hybridization in simple molecules. So first see the concept. So MOED order for less than or equal to 14 electrons. Number of electrons are greater than 14 electrons, then you follow this order. Very important calculation of bond order of molecules or molecular ions, half into NB minus NA. That means number of bonding electrons minus number of anti-bonding electrons. If star is present, that is anti-bonding molecular orbitals. If there is no star, they are called bonding molecular orbital. So next one, relations between bond parameters. N triple bond N, O double bond O, C single bond C. Which one has more bond order? In between two nitrogen atoms, 3 bonds. That means bond order 3. In between two oxygen atoms, so bond order 2. In between two carbon atoms, a single bond is present, bond order is 1. So which one has highest bond order? N triple bond N. Highest bond order means number of bonds more. To break that, more bond energy required. So bond order is directly proportional to bond energy. So more bonds, more strength. So bond strength is more. To break this, more energy required. Bond length. When number of bonds increases, bond length decreases. When number of bonds decreases, bond length increases. So single bond, more bond length. Double bond, less bond length. Triple bond, very less bond length. So very important concept. So next one, formula for calculation of hybridization of simple molecules. How to calculate hybridization means half into V plus M minus C plus A. So if you take for example NH3, nitrogen is central atom. For that central atom, how many valence electrons are present? Number of valence electrons in nitrogen atom. That means group number. Nitrogen group number 5. So here 5. M means number of monovalent atoms are surrounded by that central atom. How many monovalent atoms are surrounded by this central atom? So hydrogen monovalent atom. Monovalent atom means single bond form chese atoms. Monovalent atoms means they forms only one bond. They are called monovalent atoms. Valency 1. So hydrogen valency 1. So 3 hydrogens. So here number of monovalent atoms means 3. Here minus C plus A means C means cation charge, A means anion charge. If any positive charge is present, that positive, here minus 1. If minus 1 is present, here we add plus 1. So like this different examples are there. You observe the first question. If the bond order in C2 is X, then the bond order in B2 and O2 respectively are. So no need to write total MOED order like this question. So how to remember bond orders of some molecules? One shortcut is there. So that shortcut is if 14 electrons are present. Very easy. If 14 electrons are present, bond order is 3. 15, 16, 17 electrons. 17, 18 electrons. So less than 1. 13, 12, 11, 10 electrons. That means here number of electrons, here bond order. Shortcut. So if 14 electrons are, total number of electrons are 14, bond order 3. If 1 electron increases, the bond order 0.5 decreases. That means it is 2.5. Again 0.5 decreases, 2. 0.5 decreases, 1.5. Next 1. Same 13 electrons are there. 2.5. 12 electrons 2. 11 electrons 1.5. If 10 electrons are present, the bond order is 1. So like this, if the bond order in C2 is X, Bond order in C2 is X. C2 means how many electrons? C2 means 12 electrons. So bond order 12 electrons means bond order 2. C2 bond order 2. For C2 bond order 2. That is X. C2 is equal to X is equal to 2. The bond order in B2. B2 means boron total electrons 5 plus 5, 10. Boron atomic number 5. 2 borons, 5 plus 5, 10. For 10 electrons, bond order 11 electrons, 1.5 means 10 electrons, bond order 1. So bond order 1. For B2, bond order 1. That means how to write it is X by 2. 2 by 2, that means X by 2. So for O2, bond order, O2 means 8 plus 8, 16. Atomic number 8, oxygen. So 8 plus 8 is 16. 16 electrons, bond order 2. So for O2, bond order 2, that means it is equal to X. So respectively, B2 and O2, X by 2 comma X. So answer is X by 2 comma X. So option C. So very easy. So next one, the correct order of, so next question, the correct order of CO bond length in CO, CO3 minus 2 and CO2 is CO bond length in CO. Again CO means C triple bond O. CO exists as C triple bond O. C bond O, O minus, O minus. It is CO3 minus 2. CO2 is C double bond O, double bond O. Here triple bond is present. Here 2 double bonds are present. But here this negative charge is delocalization through double bond. That means this double bond is not a double bond. This double bond is not a single bond. Total bonds are between the double bond and single bond. They exist as between the double bond and single bond. Here triple bond. Next it is double bond. Next one double bond between the double bond and single bond. CO bond order 3. Bond order 3 means in 2 atoms 3 bonds are present. So bond order CO, next one CO2, so next CO3 minus 2. If you know the bond order, bond length is inversely proportional to bond order. So then bond length is reverse. CO3 minus 2 greater than CO2 is greater than CO. So answer is CO very less, next CO2, finally CO3 minus 2. So option C. So option next question, the correct order of bond enthalpy of given molecules is, the correct order of bond enthalpy of given molecule. Bond enthalpy means bond energy. First if you learn the bond order is inversely proportional to bond enthalpy or bond energy. So what is the bond order for O2? O2 means 16 electrons. So bond order for O2 16 electrons means bond order 2. So next N2 14 electrons. 14 electrons means bond order 3. H2 means 2 electrons. So we know that H2 exists as H single bond H. Otherwise, if you know the MOED order, sigma 1s2. Bonding electrons minus anti-bonding electrons by 2. There is no anti-bonding electrons, only 2 bonding electrons, 2 by 2, 1. So otherwise simply hydrogen bond order 1. So bond order 3 is, that means N2 is greater than, O2 is greater than H2. It is the bond order is directly proportional to bond enthalpy. So bond order is directly proportional to bond enthalpy or energy. So answer N2 greater than O2 greater than H2 or H2 less than O2 less than N2. So answer C. H2 less than O2 less than N2. The bond lengths of C2, N2, B2 molecules are X1, X2 and X3 picometers respectively. The correct order of their bond lengths. Bond lengths C2 N2 B2. C2, how many electrons? Each carbon 6 electrons, so 12 electrons. Next N2, 14 electrons. B2, 10 electrons. So what is the bond order? Bond order for 12 electrons, bond order 2. So bond order 2. N2, 14 electrons, bond order 3. 10 electrons, bond order 1. So bond order N2 greater than C2 greater than B2. Bond length means bond order and bond length are inversely proportional. So bond length B2 greater than C2 greater than N2. B2 means X3. So X3 greater than C2. C2 means X1. X1 greater than X2. So X3 greater than X1 greater than X2. X3 greater than X1 greater than X2. So answer A. So very important. Few more examples we can see. So note this. The set of species having only fractional bond order values. So very easy question. Fractional bond order. Fractional bond order means 0.5, 1.5, 2.5 like this. So C2 minus 2, N2, O2 minus 2. So C2 minus 2, how many electrons are there? 2C. Each carbon 6 electrons, 2 carbons, 6 plus 2, 12 electrons. Again minus 2 means extra 2 electrons. That means 14 electrons. Here nitrogen 7 electrons, atomic number 7. 7 plus 7, 14 electrons. Oxygen, each oxygen 8 electrons, 2 oxygen 16, 16 plus 2, 18 electrons. Each oxygen 8, 2 oxygen 16. Here plus means 1 electron lost, 16 minus 1. 15 electrons. So here 16 plus 1, 17 electrons. 16 minus 2, 14 electrons. O2, 16. Li, lithium atomic number 3. 3 plus 3, 2 lithiums, 6 electrons. Hydrogen, 2 hydrogens 2, 2 minus 1, 1 electron. Plus means loss of 1 electron. Each carbon 6, 2 carbons, 12 electrons. So N2 plus. So N2 plus means 7 plus 7, 14, 14 minus 1, 13 electrons. Only fractional bond order means easy to remember. Those electrons are odd number of electrons. Those molecules which are having odd number of electrons, so they are having fractional bond order. Easy, very easy. Those molecular ions or molecules which are having odd number of electrons, so they are having fractional bond order. So odd number of electrons here 15, 17. Next hydrogen, so N2 plus. They are having fractional bond order. So remaining all are even number of electrons. They are having not a fractional bond order. So like this example, O2 plus, O2 minus, N2 plus, O2 plus, O2 minus, N2 plus. So answer B. Here H2 plus is there, but remaining two are not a fractional bond order. It is only fractional bond order, so remaining are not. So answer B. Very easy. Arrange the following species in the decreasing order of their bond orders. Decreasing order of bond orders. Again, if you observe N2 equal to 14 electrons. For 14 electrons, bond order 3. 15 electrons, bond order 0.5 less, 2.5. 16 electrons, 2. 17 electrons. If you observe the bond orders once, so NO means nitrogen 7 plus oxygen 8, 15 electrons. Next NO plus nitrogen 7, oxygen 8. Plus means minus 1. So 8 minus 1, 7, 7 plus 7, 14 electrons. Next NO minus means nitrogen 7, oxygen 8, extra 1 electron, 16 electrons. So for 14 electrons, bond order 3. 15 electrons, bond order 2.5. 16 electrons, bond order 2. So according to this, decreasing bond order. So decreasing bond order 3, 2.5 to NO plus is less than 2.5 the 15 electrons. NO, next 16 electrons, so NO minus. So NO plus, NO, NO minus. So which one has bond order more? NO plus. NO plus means 2, NO means 1, NO minus 3, 2 greater than 1 greater than 3. So option B. So next question, if the bond order of CO is X, bond order of CO is X, CO, how many electrons? Carbon 6, oxygen 8, 6 plus 8, 14 electrons. If bond order of CO is 14 electrons, what is the bond order of O2 minus 2? O2 minus 2 means 2 oxygens, 8 plus 8, extra 2 electrons plus 2, 18 electrons. So if bond order of O2, what is the bond order of CO? 14 electrons. 14 electrons means bond order 3. Bond order 3. That is X. That is X. So if the bond order 18 electrons means 16 to 17, 1.5, 18, 1. So bond order 1. So if bond order of CO is 3, bond order of O2 minus X means it is equal to X by 3. So 3 by 3 is 1. So that's why X by 3. So answer C. See the next question. How many of these species have a bond order of 0.5? Bond order of 0.5. So like these examples, compulsory you should write MOED order. Compulsory you should write MOED order. So H2 plus. H2 plus means 2 hydrogens, 2 electrons, 2 minus 1. That means 1 electron. 1 electron, sigma, 1s1. So what is the bond order? Half into number of bonding electrons minus number of anti-bonding electrons by 2. That means 1 by 2. 0.5. Second one, He2 plus. Helium atomic number 2. 2 into 2, 4. 4 minus 1. Plus means 1. 3 electrons. For 3 electrons, sigma 1s2, sigma star 1s1. So bond order half into number of bonding electrons 2. Bonding electrons 2. Star means anti-bonding electrons 2 minus 1. 1 by 2. 0.5. So how many of the following have 0.5 bond order? H2 plus, He2 plus, He2 minus, next F2 minus. So total 4. So answer D. So next question, which pair among the following does not have the same bond order? So very easy. Which pair has the same number of electrons? They are having same bond. So Cn minus, how many electrons? Carbon 6, nitrogen 7 plus 1, 14 electrons. NO plus, nitrogen 7, oxygen 8 minus 1, 15 minus 1, 14 electrons. So both are having same bond order. So second option, Cn minus 6 plus 7, 13, 13 plus 1, 14 electrons. CO, carbon 6, oxygen 8, 14 electrons, same bond order. So if you check C, it is A, it is B. O2 minus 2, 6, O2 means oxygen 8, 8 plus 8, 16, 16 plus 2, 18 electrons. B2, boron 5 plus 5, 10 electrons. So next one, O2 plus 8 plus 8, 16, 16 minus 1, 15 electrons. Next NO plus 7 plus 8, 15, 15 minus 1, 14 electrons. Number of electrons 15, 16, 17, 18. Bond order for 18 electrons, bond order 1. The same way for 10 electrons, bond order also 1. Here these two ions bond order equal to 1, but if you observe this, for 15 electrons bond order 2.5, for 14 electrons bond order 3, so different bond order. So answer D. You can see the next question. According to molecular orbital theory, which among the following only has pi bonds? So if you observe, N2 has how many electrons? 7 plus 7, 14 electrons. Hydrogen 2 electrons. C2 6 plus 6, 12 electrons. Be beryllium atomic number 4 plus 4, beryllium atomic number 4 plus 4, 8 electrons. So if you observe, if 8 electrons means sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. So there is no pi electrons. So here no pi electrons. 2 electrons means only sigma 1s2, no pi electrons. 14 electrons, 12 electrons. 14 electrons, the bond order is sigma 1s2 less than 14 electrons. For bond order, sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. 8 completed. Next, pi 2px2, pi 2py2, 12 electrons. So pi electrons are present. So here C2 contains, after the sigma bonds filling, pi 2px2, pi 2py2, it contains only pi bonds. But if you take N2, pi 2px2, pi 2py2 and also sigma 2pz2 also present.